Hello everyone. We are going to take notes on the reciprocal function and perhaps do some examples. So let's just jump in. If f of x is equal to x plus 3, the reciprocal function 1 over f of x is equal to 1 over x plus 3. Notice on the right hand side it is the reciprocal of f of x. So when graphing the reciprocal function 1 over f of x, a good place to start is with the original function f of x. So once we have the first function graphed, that is f of x, we can graph the reciprocal function. Now how we might do that, simply we know that if we have a point xy that is on f of x, so this is one thought. Here, if point xy is on f of x, then what points will be on the reciprocal? Well, all we simply do is we take the reciprocal of the y value. So there are many key ideas. First, and I would like you to recognize that if I gave you the graph y is equal to 1 over x plus 3, you should be able to graph that immediately. This is a rational function. So we're going to be employing a lot of our knowledge of rational functions here. So we have a stationary or invariant point, they're called. When f of x is equal to 1, 1 over f of x is equal to 1. And that comes from the fact, now here we have point f of x is equal to, has point x comma 1. Well, allow me to transform that. Well, we know that a point on the reciprocal function will be, well, you take the reciprocal of 1. What is the reciprocal of 1? It's 1. So that is why, so the point stays the same, so we can say that it's stationary, stays the same, or it's invariant, it does not vary. The same argument can be made for when f of x is equal to negative 1. What is the reciprocal of negative 1? It is negative 1. Try it out. So these points are common to both graphs. Now that is a point that you can find with very little work. So keep in mind that you do have some experience with asymptotes. Now we have a vertical asymptote when our denominator are non-permissible values, when our denominator is equal to 0, we'll have a vertical asymptote on our reciprocal. And that just simply comes from the fact that we can never have a denominator of 0. Horizontal asymptotes. Now, I'm sorry, here we are. Anyways, if f of x is any polynomial function, when we take the reciprocal, the degree of the top will always be 0. The degree of the bottom will always be greater than 0. So since the degree of the numerator is less than the degree of the denominator, we will always have a horizontal asymptote of y is equal to 0. So this is true for reciprocal functions. So here I just wanted to maybe state what we've already know. The reciprocal function 1 over f of x is often a rational function. Horizontal, vertical asymptotes are the same logic that we've used before. The left-hand and right-hand side behavior are also come from the same logic that we've used before. All right. So maybe let's get started on an example. And by the way, today's being recorded in room 28, nice sunny room 28. I'm sure you guys all miss it. All right, let's get started. So one thing that I can do, grab my trusty ruler here. One thing that I can do is I'm going to start off with graphing f of x is equal to x plus 2. very simply, I know that has a slope of 1, a y-intercept of 2. There's my graph of f of x. So maybe just as we get started, I'm going to create a table of values for f of x. And I'm going to create a table of values of the reciprocal function. Now, I've stated also that we're going to have a vertical asymptote whenever we have an x-intercept. Another way of saying that is I'm going to have a vertical asymptote for my reciprocal function when f of x is equal to 0. So I guess what I'm going to do is I am going to take point -4, -3, negative, I don't know, 2.1. And I'm going to put a star beside this because it's actually cheating. I'm sorry. And then I'm going to go over here, -1.9 star. Perhaps I'm going to go -1 and 0. I can easily pluck down my x, y points here. So -4. -4 has a y value of -2. -3 has a y value of -1. -2.1, I have no idea, right? I'm talking about that y value right there. All I know is I'm going to put tilde, which means approximately. I'm just going to say approximately -0.01. And really what I'm trying to say, it's a small negative number. Now here, when x is equal to 1.9, my y value is positive. It's slightly above the x-axis, but it's still close to 0. So I'm going to put tilde, 0.1. So when x is equal to 1, we get a y value of 1. When x is equal to 0, we have a y value of 2. This is all good. Feeling pretty positive about my overall experience so far. So now, please press pause and fill out our table of values. Thanks for joining me. I'll do this again. There we have it. Now, I made a mistake here. It should be 1/2. So simply all I have to do is take the reciprocal of these numbers for my y values. And I could graph those points. So if you notice, I omitted when x is equal to -2. And that is because I know that I'm going to have a vertical asymptote. And if you don't believe me, you can write the function of the reciprocal function 1 over f of x is going to be 1 over x plus 2. You can ask yourself, where do I have a vertical asymptote? I have a vertical asymptote at -2. Now, I can take these points. So here, this is -4, -2. So when I take the reciprocal, it turns into -4, 1/2. Now, this is what is called an invariant point because my y's will stay the same, right? -3, -1 turns into -3, -1. It stayed the same. And that's going to be true for all graphs. Wherever you see your y values as -1, they're going to be common to both the graph and its reciprocal. Now, this is a little tricky here, this one. But it's more of a thought than an actual point. All I'm saying is that when I'm on the left side of the asymptote, my y value is going to be -10. And this is just a thought. Really what I want is my y value is negative and large. So all reciprocal functions that we take for sure in grade 11, we're going to have an asymptote at y is equal to 0. So you know that this function is going to look like that over here. I like to play it dangerous today. I'm graphing in pen. Yikes. That's a mistake, I'm sure. Anyways, we're going to graph the right-hand side of the asymptote in a very similar manner. So I'm not even going to look at the table. I just see where my y value is equal to 1. So I know that this is a stationary point. It's going to stay where it is. So if my y value is 2, take the reciprocal of 2, it's 1/2. Here, I'm going to say my y, so I'm talking about negative 1.9 comma 0.1. If I take the reciprocal of that, the reciprocal of a small positive number is going to be large positive. And there you have it. There is my reciprocal function graphed. If you don't believe me, try it out. Try graphing it with Desmos. All right, stay tuned.